Image Paint Production Pro is an Adobe Illustrator plugin for laser. It allows user to take a vector artwork such as this one by Kathy Wise and create this digital simulation. It then automatically creates the laser toolpaths necessary to cut the materials in order to create this physical artwork. In this video, I'm going to scan the wood veneers into JPEG images, add them into the Images panel, round the sharp corners to the laser beam radius, paint the artwork with the scanned images, add text to the design, create the laser toolpaths, cut the wood veneers, update the image to contain the cutout area, create the pocket, assemble the cut pieces, glue the assembled pieces, sand the artwork, and finally spray on 2 coats of lacquer. To start, I label and scan the wood veneers into JPEG images. Rename each sheet the same as the material database. I now create or specify where the image folder is for this project, which can be used for future projects. I then specify where the scanned images are for Image Paint to copy them into the image folder and add them to the Images panel. Before I paint the design with images, I need to round the sharp corners in the design to fit the laser beam diameter. To do this, I open the laser panel, select the artwork, select Smart Profiling as the job type, and then click the Round Corner button. As seen here, the sharp corners have been rounded to the specified laser beam radius, which is important for the laser to produce the tightest possible fit and minimize the burnt marks caused by the heat of the laser. To further illustrate why it is necessary to round sharp corners, let's cut this triangle and fit it into its hole. If the laser curve is not compensated, that is, the triangle is not enlarged by the laser beam radius of 0.003 inches, and the hole is not reduced by the same amount, these are what we would see: a 0.01 inch gap on the top side of the veneer and 0.006 inch gap will be seen on the bottom side. This is because the laser burns more on the top than on the bottom. Here, the laser curve has been compensated, but the sharp corner has not been rounded. As a result, the sharp corner of the triangle will not fit into the hole. But here, the laser curve has been compensated, and the sharp corner has been rounded. As a result, the triangle fits perfectly into the hole, but the burn edges are still visible. To hide them, we flip the veneer over and view it from the other side. This is the reason why it is critical to mirror the toolpaths when cutting with a laser. I'm ready to apply images to the design. By selecting one or more paths and click on an image swatch, Image Paint applies that image to the paths, creates duplicate paths, and places them on the image. This image is referred to as the clipper image. At this point, I can move and rotate the paths on the clipper image to achieve the desired effects, but I like to wait until all paths have been applied with images. For me, I need to see the overall view of the design with all the woods in place. I need to see how the wood color and grain combination work together as a whole before I can begin to relocate the clipper path on the image to achieve the desired texture, shadow, or highlight in the scene. It is very important at this stage to visualize which direction the sunlights come from. In this case, I assume the sunlight comes from the upper right corner in the scene. For now, I think I'm done with applying images to all paths, but to make sure, I use the verification panel to check for errors. Here it shows there are still regular paths, which are paths without images. I click this to see what they are and then apply an image to them. Here I want to use a different sheet of rosewood by dragging it into Illustrator. The new sheet is then added to the bottom of the Images panel. To replace the old rosewood image, I select it and then click on the newly added image swatch. When relocating the clipper path on the clipper image, I look for a location that can simulate the ocean waves. And here I'm placing each piece of the lighthouse so that the darkest side is to the left, since the sunlight comes from the left side. I'm doing the same thing for the roofs on this little house. For the mountain, it would look much better to have some dark stripes at the bottom, so I'm moving those pieces here. Here I'm moving these clipper paths to avoid the black areas that were used in the previous design, and trying to use the dark spots on the pimento wood burl to add more characters to the rocky terrain in the foreground. I'm thinking maybe using a darker yellow wood for the lighthouse instead of this dark brown species. That should make it more uniform in terms of color. The windows now look too contrast compared to the rest of the lighthouse. I think I will make them a little bit lighter. I should have added the artist's name before applying the images, but it's not too late. I used the text tool to add her name on top of this piece and then expand the text into paths. Since this path already have an image, I'm removing the image from it and then use Pathfinder tool to punch the text through. Now I use the verification panel to verify the design one more time. There are still a few paths that do not have images applied. Look like the foreground ocean waves need more work. Maybe adding a little more action to the waves since they are closer to shore. Now that looks better. To see how the final artwork looks like, I photograph the wooden plaque and place it behind the design. Sometimes it is better to use darker color at the bottom of a structure, so I'm using a darker yellow wood at the base of the lighthouse. It is time to create the toolpaths, but before I do, I need to make some changes to the material database. This is the material database. It contains over 140 different wood species, categorized into hard and soft types. Under each category, there are materials belonging to that category. Each material has different laser power, speed, frequency, and color mapping. Here I increase the laser speed to 50%. Notice the laser power automatically changes to keep the effective burning power the same. I need to do the same for the veneer soft category. Now to prepare the veneers for cutting, I select all the image swatches and save them as a text file and use it to pull the physical sheets of veneers later on. I'm ready to create the laser toolpaths to cut the veneers. To do this, select a master path, which in turn causes the laser panel to automatically select job type Smart Profiling. All I have to do now is to click on the Create Toolpath button. Or I can select everything and create them all at once. Let's delete the previous toolpaths. Select all paths in the design and click on the same button. All toolpaths for all veneers have been created and are visible on Artboard 6. To review the toolpaths for an image, I just select the corresponding path in the design, or I can double-click an image swatch. This is the cutter path. It has been enlarged by 0.003 inches, as specified in the laser panel, to compensate for laser curve. An important note, Image Paint mirrored the cutter image and the cutter paths, allowing the laser to cut on the negative side of the veneer. This is an additional step needed beside rounding sharp corners and laser curve compensation to minimize the burn edges seen on the positive side of the veneer. Here I'm creating a pocket for the artwork and the text to fit inside. To do this, I hide all layers but the pocket layer. Release compound path, select the ellipse, select the material for the plaque, select job type Smart Pocketing, specify which artboard to place the pocket on, and then finally click on the Create Toolpath button. The color of the toolpaths is as defined in the material database for the chosen material. If your laser has color mapping, then its speed, power, and frequency settings will be automatically set by this color. Let's zoom in and take a look at these toolpaths. There are 3 lines wrapped around a solid ellipse. The laser will raster the solid shape and vector cut the outer lines. The outer lines are necessary to produce the most accurate pocket possible with the laser. Here I specify Illustrator to print only paths on artboard number 2, which was named artboard 6. Set up the epilogue printing preference. Specify the laser frequency, speed, and power as seen on the laser panel for that material. Strange, but for the epilogue laser, I have to click Setup and print buttons again, otherwise it won't print properly. If your laser does not support printing from within Illustrator, you can export the toolpaths to .dxf or .svg file and print them using the software that came with the laser. To create the pocket with the laser, I set the vector cutting parameters as before. But this time, I also set the laser raster parameters according to the material database. As mentioned earlier, adding vector cutting is required to achieve the best possible accuracy at the outer edges. Now I need to update the images to contain the cutout area, so I can avoid them the next time I reuse those veneers. To do this, I select the cut image and click on the Image Update button. A faster method is to select all master paths in the design and click on the Image Update button. The updated images will not be visible until after I close all document and reopen the Lighthouse document. Now I can reuse the veneers to create the same or a different artwork. Here my daughter is helping me setting up the laser for cutting the veneers. She uses 2 spare pieces of wood as blockers to achieve repeatable veneer placement on the laser bed. The veneer sheet is then placed upside down with its label at the top left corner of the laser. In summary, I took a vector artwork, rounded the sharp corners, applied the scanned images to the design to come up with a simulation on the left, and create the final artwork on the right. ImagePaint did a great job of aligning the wood grains and figures to match the simulation. Thank you for watching. If you've learned something from this video, please click the like button and subscribe to my channel. Until the next video, have fun with your next laser project.